Alright, hello everyone, it's October 20th. Alright. Let's see if we can get this one. Constrained subsequence sum. Given an integer array nums and an integer k, return the maximum sum of a non-empty subsequence of that array such that for every two consecutive integers in the subsequence I and j, the condition j minus I smaller or equal to k is satisfied. So what are we returning? The maximum sum of a non-empty subsequence of that array such that, so a subsequence is by deleting something, yeah, such that what? For every two consecutive integers, so the two consecutive integers, the indices cannot be more than k apart. So, and this cannot be 2 apart. So pick this. Cannot be 1 apart. So we have to smaller or equal to 1. Oh, because there's no requirement on how many to include, so we can include only 1. Is this like Cardane, like extended Cardane? Oh, I shouldn't say Cardane. Extended. No, Cardane is maximum subsequence sum, right? Maximum subsequence. No, that's not subsequence. Subarray. Cardane is subarray. Cardane is subarray sum. This is subsequence sum. But we have. Wait, hold a second. This one seems familiar. I've done this before, didn't I? It feels familiar to me. Feels familiar. But anyway, familiar or not, I'll have to redo this from scratch. I'd like to try the last example. All right, it's 10 minus 5. Come on, minus 5 and a 20. Okay, so most likely we're gonna go with dp. So let's say dpi, okay, is the max sum up to I. Now if that is the case, right, and then we have every single one, then we find a new one depending on k. All right, so I can check this because it's smaller or equal to k, right? Smaller or equal to k, so it would be 1, 2, 3 all the way to k, or 0. We can do 0. 0 means just by itself. So I should check this, check this, check this. Okay, so at every time, for each one, we need to find the minimum of a k, right? The minimum of the previous k, because we can say 1, 2, right? Minimum of k. No, not minimum, maximum of the k. That's maybe we can do a so we need to know the maximum of a maximum of a sliding window. How do we keep track of the maximum in a sliding window? Well, the maximum of a sliding window, we can use a priority queue, right? That will work, a priority queue. But I'm trying to see if there's another way to do maximum. Let me think. Is there another way to keep track of the maximum in the sliding window. Now the sliding window is we have a new one in and old one will pop out, right? Yeah, the only thing I can think of right now is priority queue, which will work, which will be O(n log k, right? O(n log k. So it will work. For example, yeah, we start building, right? So we have 10. So initially it's 10. So we put it inside, it's 10. And then -2, right? On -2, we will put -2. So we have a 10. And then we find the maximum, right? It's 10. So 10 plus -2 would be 8. Okay. Next one is -10, right? -10. And then I need to find, so we can do -10 is the base case, or we find the maximum of this, which is 10. So it'd be 0, right? It'd be 0. Then I'll put 0 in it, right? Put 0 in it. We'll pop 10, right? I'll pop 10, so it'll be 8 and 0. Next, we'll do, oh, hold a second, that's not right. Yeah, that's not right. There's a 10 -2 -5. Wait, hold on. Yeah, it's right. So like it's 8 and 0, which put in here, right? Next one's -5. So it'll be 3. So now it'll be 0 and 3, right? Because 8 get popped out. And of course, anything that's outside the range gets popped out as well. Next is 20. 20 we pick 3, so it's 23. So yeah, it will work, but the priority queue requires gonna be a tuple, right? Because we need its index and we need its value. The index will determine whether it's gonna be popped or not. So yeah, it will work, but I feel like if you do sliding window, there gotta be a different way to handle the maximum. I always forget what would be the way to handle the maximum. Max. Yeah, I don't think it will work. Like, you just keep track of the current max. What happened? The hell happened? IntelliJ is now working. Oh shoot, I forgot where I put it. No, I think it's desktop. LeetCode. Wait, hold on. No, not here. I think it's ideal project. Yeah, dude, it's not working. What the hell? Something is wrong with my IntelliJ. Something is wrong with my Java, actually. I mean, I think that's more serious issue. Something is wrong with my Java. I cannot open IntelliJ. Interesting. No, I don't think these are the problem that I have. That was a weird issue. Yeah, this laptop is starting having weird issues. Very strange issues. Yep. There is something that's running. Okay, so let me I have data grep running as well. Let me exit data grep. because that I know. It's also IntelliJ, not IntelliJ, like probably Java based. I need to turn off everything that's Java based. I think that's about it. Everything's Java based, right? Now I try IntelliJ. Yep. Yeah, I think, I don't know, maybe a memory issue, because I've been having the data grip open for, I don't know, for like more than a month. That could be the reason. All right, anyway, so what we need now, I need a priority queue. Priority queue int, okay. PQ goes new priority queue. Okay, so I have a priority queue, and then we're just gonna go through the whole thing. But I need a res equal to 0. Oof, cannot equal to 0. I need it equal to, let's say, let's give 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 zeros, just in case. So we have the res, and then we go to 1 by 1, right? We go 1 by 1. So for int I equal to 0, I smaller than nums dot length I plus plus. So for each one, if the length, if pq dot size is smaller than k, then pq dot add new int. Oh, I need to define how to compare, and it has to be a maximum. Oh. Java priority queue comparator. Okay, priority queue. Size. Yeah, I don't have a size. I can have a size. Size is k. No, I can just do this. Yeah, let's just do this comparator. I think it's comparator int, and it's gonna be a tuple, right? Is it default is what? I think default is min heap, right? Natural ordering all by comparison. So if I want to get a max heap, I need to minus top 0. That's a max heap. So new int nums I and I, right? So I push this in, and then no. What I need to do is, it doesn't matter. No, I don't think this is right. I think I should just check the top, right? Hold on. While pq dot is empty, if it's not empty, and pq dot peak, yes, peak 0, no, peak 1. Index, if its index is smaller than the current index minus k. This I need to figure. because the length, right, of the window is k. So let's say the length is 3. So we have 1, 2, 3. Right, next is 4 coming in. So 4 minus 3 is 1. So if your index is smaller or equal to 1, you should be eliminated. So I must be smaller or equal to that. Then pq dot poll. Right? I don't even need it. I just, poll it. Basically, anything that's not supposed to be in this window, and also it's in the maximum position, we pull them. And once we pull them, then we don't have to check this. We always add a new one, right? We add a new one. Then, actually, we don't add a new one yet. We get a current one, right? Then we shall say the current max. Okay, so we have to int current, right? So current max is always equal to nums I. Okay. Then we say actually no. Yes, if pq dot is empty, if pq is not empty, right? Pq is not empty, then current will equal to math dot maximum current nums I plus, but hold a second. Yeah, that's fine. Nums I, it's including nums I plus pq dot poll, right? Poll 0, right? So these are the. So then we probably can just say this. We just put nums I. Oh, then no, because it might be. Because I want to avoid doing this. I mean, that's fine. That's fine. Let's just do the if, right? Current, well, equals math dot maximum current. If it's empty, then we don't do it, and then we do this, and then we add this, right? We always add a new one. Then we'll do the whole thing, and at the end we'll return res. But where did you update res? So we get a current, and then res shall equal to math dot maximum current and res. Let's give this a shot. It's not right. Missed quite a lot. 25. I go 20 and 5. Shall be the previous 3. Answer is 37. Oh, that's just from the current. We get a maximum. Wait, hold a second. We should get 10, 2, 5, because I took look of, because 5 I can get to 2. Wait, why is this not right? Hold on. Something is not right. Let's do this. 10, 2, minus 10, 5, and 20, right? So my thing is going to be 10. Oh, you're not supposed to put, I pushed the wrong thing. You shouldn't push the nums, you should push current. So current is this, you should push current. Still not right. think this is smaller because I am here, right? That's so j minus I smaller equal to k, right? So 2, so minus 1, minus 2. So at 20, I can get to 5, right? And at 5, I can get to 2. So this is 12, right? It's 12. So 5, this should get to 17. Yeah, something is not right. I think it must be here. 2. 0, 1, 2, 3, 4. 4 minus 2 is 2. 0, 1, 2. Yeah, I removed this, so now it should be smaller. All right, this is... Ugh. What the hell? All right. I think I don't know. Let me we'll have to print it out. You know what? Don't print it out. Let's debug it. Maybe the way I set up the way I set up priority queue is wrong. There are so many things that can be wrong in this, so might as well to debug to figure out, because I'm not really confident in the setup of constraint, in the setup of the priority queue. So it's a fine nums k. Okay, debug. Yeah, we put it here. All right. Nums kpq. Let's just see. Current is 10. Skip. Rest is 10. Skip here. Pushes in. Okay. PQ. PQ have 1. 10, 0. Nice. Next is 2. Is not empty. So current shall equal to 12. Current is 12. Yes. It's I is 1. All right. I is 1. PQ is 0. Wait. PQ size is 0. Oh, shoot. This is not poll. It's just it's peak. Okay, so we got the first two right. The last one is wrong. The last one. 3. Okay, 0, 1, 2, 3, 4. Right? 22. So minus is 1, is it 2? 2, 3, 4. 4 minus 2 is 2. The 2 should be maintained. I got 28. How does he even get to 28? It's not even possible to get 20. Oh yeah, is it possible? All right, let's take a look at this one. What's wrong? Okay, 8. Current is 10. First one's right. Second one, minus 2 should be 8. Right, current is 8. Res is to 10. And don't do this because, so we shall do this. Okay, so now PQ size is 2. That's correct. Next, come out is minus 10. So minus 10 shall add 10, should be 0. Right? Current is 0. Oh, you should pop. It is smaller equal to. It is smaller equal to. You're supposed to pop. So I was wrong on different front. Yeah, because you're about to push one in, right? So I have to do this. You have to be equal to, yeah. Right? Get this, yeah. But the runtime is bad, which means I think there should be a better way than doing this. Which is my guess. 1425. Use max heap to keep track of the what? Keep track of max value. It's DP. Now first we DP, where DPI, right, is the max sum up in nums, a max sum that satisfies the requirement in nums all the way to I. Actually, I plus 1, right? Then use max heap to keep track of the max DP value, in the sliding window nums I minus k to I. Right? Then this will be O(n) log n, because the size of this can be O(n), can be n, the priority queue. That's why it's slow. So what I think is there gotta be a way, right? There gotta be a way to keep track of the max value faster. So that's what we want to see. Yeah, they added one already. Yeah, maybe that's why. Hold on. Yeah, let me do this. Let me say pq.add new int. Let me add nums 0, 0, right? And then we can go from 1, and this is going to be nums 0. Then we go 1, right? And it will never be empty because it will always be something, right? Then I can just do nums I. I don't need to do this. We get that. So if we try this, maybe the runtime will be faster because I remove one of the if. Nah, it's the same. It's the same. So that's not the way. Tree map like data structure. O(n) log k. monotonic deck. What the hell is a tree like? A tree map. Max value of dp in the last k indices. We accomplished this in O log n time with a heap, but we could achieve O log k with a tree map data structure. It's a red-black tree. I think it's a balanced tree, right? Because case one is a slight improvement. Use the dp array that we spoke of in the previous approach. Had a data structure window that holds all values of dp. So I think this tree map is able to what? Easily calculate the dpi as mi plus the maximum value in the window. Now we can add the dpi to window. To maintain window, once we reach in this k, we need to start removing dpi minus k from window. We use the tree map. Each key will be a value in dp, which will map to its frequency. To remove dpi minus k from the window, we will decrement its frequency, and if its frequency becomes 0, we'll remove the key. In Python, we use sorted list. So it's sorted list, so you will remove. Yeah, so in the sorted list, yes, you add a new one and you go pop. Hey, hold on. Sorted list, how do you pop? Oh, you pop the front. Wait, no, hold on, it's sorted. Wait, how do you do sorted list? Remove window is this sorted list. dpi is this plus window minus 1. Window.add dpi. Oh, we remove the value. We remove the value. It's log k to remove the value. Oh yeah, you keep track of the value. Reach index k, we need to start removing dpi minus k from window at each iteration. So this, the key of 0 to make the code cleaner. Plus yes. So the key, tree map. So what is a tree map? A tree map is used to implement map interface. Map is sorted in according to natural order of its keys. So keys will be the index or by a comparator, depending on which constructor is used. This proved to be the efficient way of sorting and storing the key value pair. The storing order maintained by the tree map must be consistent with equals, just like an order. Tree map implementation is not synchronized in the sense that if a map is accessed by multiple threads concurrently, and at least one of the thread modifies the map structure, it must be synchronized externally, so it's not thread safe. Tree map is a concrete implementation of the Java sorted map. An ordered collection of key map pairs where the keys are ordered based on their natural order of a custom path. So the keys are ordered. A red-black tree is a type of self-balancing binary search tree. This provides efficient performance for common operators such as adding, removing, and retrieving. Hold a second. The keys are, therefore we are getting, look at that, when we put a value because the keys are sorted, right? The keys are sorted. Okay, so the keys are sorted, and we'll put 0 and 0. That I do not understand. Why you put 0 and 0? What is this 0? Oh, I see. I see. Yeah, that's fine. That's fine. So we go through them, right? Oh my god, have a last key. It has a last key function. What? Do you gotta tell me what are the functions? Constructor, what are the functions? Clear, clone, contains key, entry set, contains value, first key, the lowest key. Oh, you get head map, key set, last key. Oh, woo. Last key. So yeah, so you put the key is the DP value, right? You put the key, which is the DP value. And what's the value then? The value should be the index. But how do you remove? Do you have remove? Put, remove. Remove the mapping for this key. If you remove the mapping, so how do you remove based on the index? In Python, we just remove the value. Oh yeah, you remove the value. Yes, you just remove the value. Then what is the purpose of the value? You put it in and you need to remove, right? You need to remove. So when you remove, you just need to check. Yeah, because you already have a DP, so you check the DP value and you just remove that value. Oh, I see. You cannot remove that value unless there's only one left, because you need to first decrement it. Ah, but how does Python do it? Python is a list, so it doesn't matter. You can remove one, it will be another one left. I see. Oh, this is good. This is so good. Monotonic deck. I knew it. I knew there will be a monotonic. Alright, hold a second. Let's implement this one first. So this one is using tree map, which maintains the order of the keys. So if we put DP values as keys, we will always be able to obtain the max DP value in the sliding window. Then we simply in the tree map, right? In the tree map, we treat the tree map. We treat the tree map as a counter, so that when we remove a value from the tree map, we first decrement its count. If the count becomes 0, we remove that map, that value, that key value pair. So we don't use this, right? We say tree map, integer, counter, new tree map, and we say int dp nums.length, int res or equal to nums0, right? And then counter dot put nums0 1, right? And that's about it. And then we'll go 1 to the end, right? So whichever comes out, oh, and then dp0, and dp0 equal to nums0. Okay, then we say dpi shall equal to max max dpi, right, by itself, or counter the last key, which is the biggest in the previous, plus nums_i plus nums_i. Will be these two. Either we use myself or we do that. So we get a DPI. Now once we get DPI, we need to get res or equal to math.max res and the DPI. That's normal play. And then we say if I is larger than k, so 0, 1, 2 equal to k, right? We need to remove. Then we say counter dot put, right? dp I minus k, that's the one to be removed. Counter dot get dp I minus k, get our default, right? dp I minus k. Now we don't have to do dp, we don't have the default because it's always going to be there. So we can just get, right, -1. Then we say if counter dot get dpi minus k. If that becomes 0, then counter dot remove dp I minus k. But you need to add. Where are you adding it? I don't see you add it. Counter dot put dpi counter dot get or default. That's what we have to go get or default. pi 0 plus 1. Right, we add 1 or remove 1 at the end of return. So this is on log k. We'll see a performance boost. I don't see a performance boost. Must because a tree map. It takes more time to set up the tree map, but theoretically, this is a faster method. All right, last one. is priority queue. No, that's a priority queue. It's a monotonic array. Monotonic deck. Let's see if you can figure out yourself. Monotonic deck. Like, so in this case we have 10. Let's say it's monotonic decreasing. Monotonic decreasing, so 10, 12. I'll pop this out because it's monotonic, so we'll pop this out. Right? So it's 12. Next will be 2, because this, right, commenting will be 2. Next is 5. 5 I get to 17. And then 5 I need to push the in. Okay? So, but before pushing in, we need to, because the size, right, it's so I also have the index. Okay, so I have the index as well. Okay, I have the index. And then once we've done this, we index, so we pop the front, right? And then we push this in. And then we'll pop from the back. So in this case, we'll end with 5. Right? The last one, not 5, 17. 17. And the last is 20. Yeah, maybe I can. Monotonic deck. I can just use a deck. I think it has a deck. So this is monotonic decreasing deck. ON. Yeah. Okay, what do you think? So we'll do a deck. Do they have a deck? Yes, they do. Int mon. No, I think it's linked list. Right? That's what we need, a linked list. So nums mom dot put, now put add new int your number and your position. Okay, and then for this, okay, then what? Now I'll get into current. So this will be current equal to max this, and this is going to be monotonic dot get first 0, because that's the biggest, plus the current. Okay, so we got the current, rest, okay, current done. Then let's do the monotonic thing. So maintain add current while mon dot is empty. If it's not empty, and what? If it's not empty, and mon dot get last 0 is smaller or equal to current, because if it's equal to, I'm gonna pop those as well, because I can push my current one in. Then we say mon dot remove first. Okay, then remove any element that is outside the current sliding window, while not monotonic, that is empty, and mon.get first 1. Okay, if that is smaller or equal to I minus k, mon.remove first. Shoot, that should be last, right? Oh, you have an add. Mon dot add. Oh, last. Yeah. Add last. New int. Current I. Now remove the front. Done. Does it work? Oh, oh, oh. Damn. Works. Oof. What a solution. Monotonic decreasing. Yes. Yes. Oh, that's, yeah. Oh, that's not right. What if everybody is negative? Poll. Array deck. Oh, you can do array deck. I didn't know this exists. I use linked list. Array deck. Array deck versus linked list. Thank you. So I should use, yeah, we should use the best practice. It's performance. So it'll be array deck. Dude, they have the same API. Array deck has at last as well. Oh my goodness, that's the only thing I need to change. They have the same API. Well, if you think about it, it is the same. Because they both can be called a deck. Of course they have the same API. Oh, it's even faster. It's even faster. All right, that was good. Deep merge. I've done this one. That's pretty good. Query batching. We have one problem, two problem, two more problems. Oh, it's all hard problem. Wait, what is this? Build array where you can find maximum exactly k. Well, that's just a problem. Oh, then. Okay, so this is a regular problem. It's just a hard problem. I'll move it somewhere else. Yeah. Now, these JavaScript problems should have a higher priority. Here you go, JavaScript, no, 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 and no. Okay, so what is this? Batching multiple small queries into a single large query can be a useful optimization. Write a class query batcher. Implement this functionality. The constructor should accept two parameters: an async function, query multiple, which accepts an array of string keys input. It will resolve with an array of values that is the same length as the input array. Each index corresponding to the value associated with input I can assume the promise will never reject. Throttle time in millisecond. Class has a single method, get value, accepts a single string key, and then resolves with a single string value. The keys passed to this function should eventually get passed to the query multiple function. Query multiple should never be called consecutively within t milliseconds. The first time get value is called, query multiple should immediately be called with that single key. If after t milliseconds get value had been called again, all the past keys should be passed to query multiple and ultimately returned. You can assume every key passed to this method is unique. The following diagram illustrates how the throttle algorithm works. Each rectangle represents 100 milliseconds. The throttle time is 400 milliseconds. So input event is get value, right? Get value, get value, get value. So get value, throttled event, query multiple. Wait, hold a second. An array of string keys will resolve with an array of values that is the same length. Each index corresponds to the value associated with input I. Assume the promise will never reject. A throttle get value accepts a single key and resolve with a string. The keys passed to this function should eventually, the key, eventually get passed to the query multiple function. Query multiple should never be called consecutively within t milliseconds. So there's a throttle. Do you remember how to do throttle? I don't remember. I think there are multiple ways to do throttle. I think one of them is, which one is the easiest one? I think it's interval, right? I think it's the interval. Should never be called consecutively within t milliseconds. The first time this is called, this should immediately be called with that single key. If after t milliseconds having called again, all the past keys, if after t milliseconds get called again, then all the past keys should be passed and ultimately returned. You can assume every key passed is unique. So I throttled events. I don't think this is right. I think you do this call, you get this, right? And you call this one again, and it shall save this, and save this, and then after this it calls, it shall get both, right? It should get both. I don't think this is right. I don't think this input events is right, because in this case, right, batcher, query batcher, right, query multiple, we call this, we get in this, right? And we call this again because it has a throttle, so it won't call this. It won't call this, but these two gets batched. So after 100 milliseconds, both gets returned. So at time 10, we do this, and then these two gets batched. So at 110, both gets out. And the rest is immediately returned. But the query is queued. The query is queued. Yes, that's what I understand. So I think this is not, this is confusing, right? I think this is not right. It didn't reflect the fact that these gets called as well. Okay, so I feel like it's the same, so I just need to implement a throttle. But how do we implement a throttle? I don't remember. I did it last time. If I remember right, throttle. I need a key, right? I need the keys to keep track of the keys. And when you call get value, right? When you call get value, if there's no key, okay? So if keys is null, that we haven't get any keys yet, then you call query multiple. So I probably need to, this dot query multiple equal to query multiple, this dot t equal to t, okay? So we probably need to, and then every t, then we check this function, right? We check this function. And but get value is async, right? Get value is async, which means it will return something, right? It will return something. So when we call get value A, I will return that immediately. If I call get value B, it's within the interval, right? It's within the interval. It's within the interval. Now I think interval is hard for me to reason. I'll just get timeout, set timeout. So we'll set timeout to t, right? And during the set timeout, then what do I return? Exactly, what do I return? We return something, right? And then the resolve. So we'll resolve what do I resolve? Resolve the resolve need to wait, right? The resolve basically need to wait until the query multiple is called. Yeah, the syntax of this I forgot. It should be some function gets called and then we resolve, right? Some function gets called, then we will resolve. How do I do that? I need some inspiration from the previous. I mean, I forgot how how is that done? Yeah, how do I do a promise that we will only resolve it or reject it when a function is called? I don't remember. don't remember the syntax. JavaScript. Resolve promise only when a function is called. That's not what I want. Or can I just pass? Hold on. A promise. What's the constructor of promise? New promise. We pass two things. Can I pass the resolve function? I don't know. I forgot. It's not these. It's JavaScript. What is that thing that I did in the past? Oh, have a new problem coming in. Ha. What is the problem that I did in the past? Is it debounce? Is that curry? Promise pool. Promise time limit. Not this one. Something with cancel. Cancelable function. Here, that's the one. Let reject function. Cancel promise. A new promise. Reject. So reject function becomes the reject. So whenever I call this reject function, this won't get rejected. Okay, so here will be the same, because I need to call it, right? So it's going to be a promise. So the resolve function will be some function. Okay, resolve function will be some function. And then when that function gets called with a value, then we will resolve. Okay, so that's the return value, right? Return value. And we have a key, right? We have keys. So key value. We'll push it in and it will return. So it will be key. The value shall be the resolve function, right? The key shall be, so the key value pair is the key and the resolve function. That's when we return. And then, so it'll be something like this. This dot key resolve shall equal to a this. Okay. And then once it comes in, right, then we just need to write a throttle. I just forgot how to do throttle. We need to do a throttle. Keys, right? And then this dot keys empty, right? So when there's no keys, so you're the first one, so you just return it. Okay, so if keys dot length, this dot keys dot length is equal to 0, then we'll just return query multiple key, right? Await 0. That's it. Okay. But how do you wait if you call again? Yeah, and then we shall say this dot waiting is could the key length equal to 0? So it should length equal to 0 and waiting is false. It's not waiting. So if this and not waiting, then say this dot waiting equal to true. Right? Then how do I know when the next one should be called? How do you do throttle? Come on. I forgot how to do throttle. I'll do the first one, but then I need to throttle. But how do I know throttle T? Call get value again. And then this is like to capture the current time. I don't like the current time method. I like the get timeout. Oh. Set timeout. Then when the timeout then will become when timeout will become true, waiting will become false. Hold on. If it's not waiting, okay, if it's not waiting, I'll call it. Hold on. Let me redo this. if it's not waiting, and we call it, we'll get it. Okay. Okay, every time we call it, how about this? Every time we call it, keys dot push, right? We always push it. And now we say if we are not waiting, then const res list or equal to await query multiple this dot keys. Okay. And then let resolve function and const res promise equal to new promise resolve resolve function equal to resolve. That's the trick. Maybe I can do this. Right, so that's the return promise. Okay, that's a return promise. And we say if it is not waiting, and we'll put this dot key resolve. Can I say each key is unique? Every key passed is unique, so this will be key equal to resolve function. Okay. Now, if it's not waiting, then we'll do this. Okay. After we do this, we'll go through the rest list. We can say for int I let I equal to 0, I smaller. Oh, we can say let I in. Doesn't matter, this dot keys. Okay. This dot key resolve. This dot keys I. We shall call res list I. So this is the resolve, right? We'll resolve all of them. After we resolve, we're done. Yeah, we're done. And because give value can keep getting called, but query multiple cannot. Query multiple can only call every t milliseconds, right? Query multiple is only called every t milliseconds. So when this is done, we can set this dot waiting equal to true and set timeout something with this dot t. Right, when this is done, we should say this dot waiting equal to false. Right? So if it's not waiting, we do this. If it is waiting, we set it to true. So the next time we call get value, we'll check this dot waiting is true. So we don't go this, now we'll go here. This is when the waiting is true. Right? Else it is waiting, then oh, I already did this dot keys. I push the key, I produce a new, and I'll just return promise. And once this is done, I think I need to clean. So I should say this dot keys equals this, right? Just clear out this dot key resolve. Do we have a clear? Const A equal to 1, 2, 3. Const B equal to 1, 1. A dot clear. B dot clear. Console A so log B. Do we have that? Clear is not a function, so there's no clear. Map has clear, set has clear. Array, does array has clear. Prototype, at, concat, copy, entry, filter, fill, each from. Yeah, I don't think it has. That's fine. Oh, we just reset them, right? Reset, because I handled all the keys. What do you think? You think this one works? We reject. Wait, what is not query multiple is not of course it should be this dot query multiple. Ew, I got nothing. It's not working. What? It's not working. But that was how I did this one, right? Cancel is a function when you call it. We'll call this. It will call this. Hold on, let's just make it simpler. Let's just do one, okay? Just do one and see how it goes. And let's just, console this dot keys I res list I. Oh, this one's good. It's when we have multiple. It's we got two. That's when we have issue. Nothing gets output. So okay, so we got the first one coming in. We call get value. Dot push. Resolve as fun. Oh, because at the end nothing gets. You set timeout. You need to call some function. Come on, you need to call some. You need to call this again. Yeah, that's the problem. We did not call it again. We did not call this function again. So get value. We need another function, right? We need another function. Yeah, you set timeout. You need to call it again. So get value is get value. You can't just call get value again, right? You can't. Maybe I can. So to set timeout, I call it again. And if it's not waiting, right? So it will be undefined. And we'll say if key is not undefined, then we do all this. And in fact, if key is undefined, hold a second, I think this is when key is not undefined. We do all this. Okay. If key is not undefined, I'll do this, blah, 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 and then this will be a function call. Okay. And then we'll call this dot get value. Actually, I want to double check that. Say const a equal to key, I don't know, console.log key. Oh, that's perfect. So I can call a1. Okay. Then I call a itself. Yes, it's undefined, right? So if it's undefined, that means we call it here. Right? We call it here. So we'll call this again, and this is undefined. But it is not undefined. We do this. We say if key said that. Otherwise, right? Otherwise, if it is undefined, then we need to do this. Do this part. Hold a second. So no matter what, we need to do this, right? But only if key is not undefined, we'll update this. If we're not waiting, then we always do this, right? Timeout. Then we'll call this again. Okay, we call this again. And this is not waiting. And this dot keys dot length is larger than 0. Then we do this. Right? And then we say if key is not equal to undefined, we'll return. Oh. Let return promise. Okay. Doesn't matter, we just return ret promise. Inside here, that don't really care. Okay, let's try this one. Now this is the recursion version. Okay, it's now right. We need some more work. We'll deal with this tomorrow. We'll deal with it. I think we have the basic structure, so we just need to deal with this tomorrow. All right, I'll see you guys tomorrow. That's late. Adios.